They did not have Daniel Cook in Brazil. They did not. Huh? All right, here we go. Before we go any further, I need to remind you that what a rational number is. A rational number is anything written like this, but there's some rules. What are the rules? Y can't be 0, and X and Y must be integers. So we all know how to deal with that. And we all know, don't write down what I'm about to write down, we all know that this can't be done. Why? What is wrong with what I've just written there?
That's not the same. You can't simplify it.
I cannot add them because of what reason?
Because the denominator is not
the denominators are not the same. Which means that is not allowed. Wait. Big red X. No. What about this? Is that allowed? No. What about this?
No.
Yes.
Oh, yes. Sorry.
Why?
Because you're multiplying.
Because you're just multiplying. So this answer would be XA over YB. Right?
Yeah.
What about this?
Yeah, you can do it.
No. You have to do something to that. You can't do that right now. What do you have to do?
You need to flip it.
X over Y times B over A. Now it's okay. Everybody knows this from grade 4, yes? Which means, since rational numbers are rational expressions, then multiplying and dividing rational expressions must be exactly the same as multiplying and dividing rational numbers. And you already know that. X over Y times A over B equals XA over YB. And X over Y divided by A over B equals X over Y times B over A, which equals XB over YA. You all already know this, yes? Now, if I gave you a question like this, all of you immediately, I don't know why, but almost all of you remember grade 4 and Mrs. Bad Crumble, who spent a year and a half to teach you how to add and subtract fractions. When you got to multiplying, she said, class, remember how when we were learning to add, you all wanted to just add straight across? Where 3/4 plus 2/3, you all wanted it to be 5/7, but it wasn't? You all said, yeah, Mrs. Bad Crumble, we hated that. Then Mrs. Bad Crumble said, good news. When you multiply, you do get to go straight across. Which is wonderful, except you've just spent the last 3 months practicing not going straight across, haven't you? And then Mrs. Bad Crumble says, go straight across. And then 3 weeks later, she gives you this question. After you've been practicing for 4 weeks to go straight across, and then you go 9 over 23. And then she says, Louis. And then instead of a gold star, she gives you a silver star to keep your feelings from being hurt. Right? You all remember this, yes? You all heard that from your teacher. Remember, now we get to go straight across, which is really a bad thing, isn't it? Because then you start going straight across, even when you're not supposed to. Okay? So, All of you will straight across here, and almost all of you, if I said, what's the answer to this? Almost every single one of you is going to tell me it's 20 over 120. And then what are you going to have to do? Simplify it. How? By what? 20 will work. 1 over 6, right? Now, of course, what you really should be doing is applying the principles of mathematics. 5 over 8 times 4 over 15. Do the order of 5 times 4 matter? No. Is 5 times 4 the same as 4 times 5? So couldn't I rewrite this as 4 over 8 times 5 over 18? 15, I mean? Couldn't I? Yeah. Which would, of course, be 1/2 times 1/3, correct? Yeah. Which would, of course, be 1/6. Yeah. Easy peasy to switch them around. What? I'm getting to that, Anna. Don't give me away. Now, this is really easy to fathom, yes? Because we understand that multiplication, this is saying 5 times 4 over 8 times 15. So I can change the order in any way I see fit. But when we're dealing with rational expressions, is it rarely this simple? No. So what I am talking about with Anna and getting her out of my brain is 5 over 8 times 4 over 15. You can look anywhere up and down. Yeah. And you notice that 5 and 15 both divide by 5. So that 5 cancels and becomes 1. That 15 cancels and becomes 3. Then you notice that 4 and 8 work together. 4 becomes 1 and 8 becomes 2. 1 times 1 is 1. 2 times 3 is 6. And all of a sudden, it's super easy. Now, if this applies to just plain numbers, doesn't that mean it will apply to expressions? Yes, as long as everything is in the same form, right? So let's look at this very first question. What is different between this side of the expression and this side of the expression? One is factored and one isn't. So are they in the same form? No, because pink guy is not factored, whereas green guy is factored. Factoring makes things simpler. So let's factor pink guy. How can I factor that? A minus 4, A plus 3. How can I factor that? A plus 3, A minus 3, times A minus 3, A minus 1 over 2, A minus 4. Now, when I had all numbers and anything worked up and down, I could cancel, yes? Do I have any of that here? A minus 4, A minus 4. One's up, one's down. What happens? Gone. Gone. A plus 3, A plus 3. What happens? Gone. Gone. A minus 3, A minus 3. What happens? Gone, gone. What's left? A minus 1 over 2. Now, something is missing. What did we do? What was the very first thing we learned in this unit about rational expressions? Restrictions. Read the definition.
No denominators in the whole expression can ever be 0.
Okay. So, here, the denominator is 2, yes? Can 2 ever equal 0?
No.
No. So when it's simplified, are there any restrictions? No. But when is there ever allowed to be a 0 in the denominator? Never. So where in this do I actually have to check for restrictions? At the end or somewhere before then? Somewhere before. Where are the denominators? Right there, correct?
Yeah.
A plus 3 can't equal 0. A minus 3 can't equal 0. A minus 4 can't equal 0. So A can't be plus or minus 3 or 4. Does everyone understand?
Yes.
Everyone is good? Does it matter how yucky this gets looking? No, because you follow the same rules. What are those rules? The same rules we always follow. Simplify first. What is the number one thing we do to simplify? Factor, factor, factor. What did you say, Myers? I said factor, factor, factor. But surely you don't mean every factor, factor, factor. But Myers, factor, factor, factor. But when should I stop that? When you can't. So how long do I factor? All the time until you can no longer. So, is that an expression?
Yeah.
What should I do with it? Factor it. Y plus 3, y minus 3. Is that an expression?
Yeah.
What should I do with it?
Oh, it's weird.
That's okay. You have it right in front of you. You know the last thing I highlighted was the denominator under y squared minus 9. What should you be doing while I make my computer come back?
Bracket R minus
Factoring.
1.
R squared, r minus 1 times. Is that an expression? What should I do?
Factor.
Yes.
How did you take r squared off?
Oh, sorry, just r.
Oh yeah.
What?
R squared minus
Oh, yeah.
1. And then, what do I got up here? The blue one? What's coming out? R minus 1. And is there any factoring to be done? What color haven't I used? Is there any factoring to be done there? So I can leave it as r plus 3. Factor, factor, factor. When? Always. Factor, factor, factor. For how long? Till you can factor no more. What do you see right there? Can I factor that? To what?
R plus 2. Plus
R plus 1, R minus 1. When everything is factored, what should I check for here?
The restriction.
Check restrictions. When done factoring. So, this one, R plus 1, no, wait. R can't be 0. R plus 1 can't be 0. r minus 1 can't be 0, and y plus 3 can't be 0. What are my restrictions? What are the 4 numbers that I'm not allowed to have? 0,
-1,
plus or minus 1, and
-3.
-3. As long as my variables aren't them, I'm good. Right? Now let me ask you this. Can r be -3? Yes or no? Yes. Can y be +1?
Yeah.
Yes. So is this technically right? It's all the restrictions, but is it right?
No.
Does that get you full marks?
No.
R can't be 0 or plus or minus 1, and y can't be -3. That's the best answer. Everybody good?
Yeah.
Now, is everything factored? What do you see there and there?
The same, so delete.
Gone. What do you see there and there? Gone. What do you see there and there?
Delete.
Gone. What's left?
Y minus 3 over r plus 1.
Done. Does everybody understand?
Can you do the same thing for like the bottom left and top right?
Bottom left.
Yeah, like on the r cubed minus r squared minus r, then you take out the r.
Yeah.
And for like the top right, can it be like r minus 1, r plus 1?
No. Because that's not a 1. That's just an R. Now, please notice, remember in grade 10, if I taught you, I told you that there's no real life use for factoring, it just makes life easier? Here's where it's happening. It makes your math life easier. Turn the page over, and again, I call your attention to something that looks different. But is it? No. Factor, factor, factor. Do you see any factoring you can do there? It's very tricky. Well, that's only one thing, so there's no factoring there. What could I take out of there? Okay, so those guys aren't changing. What else? This always messes you guys up. 2 pi r, 2 pi r. What do I get to get rid of?
2 pi r.
The 2 pi r. Leaving me with what? dh over what?
Over d negative minus
d minus 2. Now, almost all of you are going to go a step further here. What are you going to do?
the restriction.
No, you need to check your restrictions. You should have checked your restrictions back here where it was factored. R can't be 0. And D can't be
Positive
2. What are almost all of you going to do there? Because you haven't been listening to me, you've been only half listening, you're going to see, oh, D on the top and bottom, cancel, which you can't. A bunch of you are going to do that. Even though I've just done this, you're still going to cancel that. Why can't you? It's not multiplying. The same reason you can't do this. Cancel. Okay? You can only cancel units. This denominator is not D, it's whatever D is minus 2. This numerator is not D, it's whatever D is times H. So you cannot cancel them. Same as this one, D over D plus 2. You cannot cancel those D's. All right? What's different about 4?
It's dividing.
It's dividing. Now, this one is really tricky for a couple of reasons. Okay? 1, you notice that it's division. So what it really has to happen on this side of this expression,
Flip.
I got to make this times the reciprocal, don't I? Well, just wait a second. Everybody knows that, yeah? But what does that mean happens when I'm checking for restrictions? Where do I have to check for restrictions? Denominators. When?
Right now.
No.
After you flip it,
When do I check? When can a denominator be 0?
I'll be factor.
Never. No denominators ever. What happens to that numerator when I reciprocate? It becomes the denominator, which means I have to check how many expressions for restrictions. No, more than 2. I have to check that denominator, and once I flip it, that's the denominator. So I have to check all 3. Does everybody understand? In a division question, the reciprocal means we must check more spots for restrictions. When do I check for those spots? After factoring, before canceling. So let's go. What is this first expression that I didn't highlight at all? How do I factor x squared minus 4? X minus 2, x minus 2? X minus 2 and x plus 2. Yeah. What am I factoring down there? In yellow. What can come out of there? X out, and that leaves what? X minus 4. Everybody cool? Now I have a choice here. I have a choice here, which means what do you have? A choice. What do you think I do? I flip this right now. And I factor this blue guy up here, and I factor this green guy down here. But then I remember that I got to check all 3 highlights for restrictions. Restrictions are the highlights. Damn, that was almost perfect. Right? So, what is that blue guy going to become? He waited patiently for the grade 11s to do their grade 10 factoring that we reviewed this year.
X plus 5.
X
minus
plus
4.
5.
X minus 4.
X minus 4. And what will this green guy be?
X plus 3 and x negative 2.
Now I check my restrictions. The yellow one. X cannot equal 0. X cannot equal 4. That's the yellow one. A bunch of you got that wrong on your last 2 tests. Do all of you know why it can't be 0 now? Good. Blue one. X cannot equal negative 5 or 4. That's the blue one. Does everyone know why? Know why. And finally, x cannot equal negative 3 or 2. And that's the green one. Everybody knows why? Lucas.
I didn't understand why did you do the blue one. I just did the yellow and the green, like the restriction.
Because at the beginning of the question, this blue one was the denominator. Okay? Because, here's another reason. If the top one is 0, this green one, if this works out to be 0, 0 divided by anything is still 0, yes? But then I'm doing this divided by 0. Oh, that's not allowed either. Okay? So now, can I start canceling? Where? X minus 4, X minus 4. Where else? X minus 2, X minus 2. Anywhere else? No. Final answer, X plus 2 over X, X plus 3. And we're done. Is everybody good? What? Where's, oh, I forgot X plus 5. Thank you. Is everybody good? There's, how can you solve it? But standard form, we want it as simple as possible. What's simpler? 144 or 12 times 12? Right? This is how I want it done. Factored down to nothing. Everybody cool? You guys try 5 by yourself. Work with your neighbor if you need to. I'm going to pause for a moment. Factor, factor, factor. Check restrictions. Cancel, cancel, cancel. Answer. How many versions of factoring do we have? 3. Right? 4 if you include difference of cubes, but I'm not going to do that to you. Well, I might. I'll try not to bully you. You might need to do trinomial factoring. You might need to do difference of squares. And you might need to do, trinomial with a leading coefficient. Stop it. What's different about 6? Oh, first of all, did everybody get 5 right? Are we cool? Are we cool? Okay. So, there's something I should add to 6 to make it look better. What? There you go. Now it's easier to deal with. What am I going to do there? You're going to factor it. What is it? Do people need to be reminded how to factor these? Yes? No? Maybe? You don't need to worry because Jazzkarn's going to come up and factor it for us. No, you're going to come up and factor it for us. Right here. You're talking with Tirith. You must know how to do it perfectly so you can come up and teach it. Careful, because some people actually needed this.
This one, right?
Yeah. No, I'm not a barbarian. Use my seat.
Thank you.
No problem.
Wait, can I just write on?
Yeah.
Three. And then it's plus 3. That's it. Factor, right?
3 times 16 is 15.
No, that's 10.
3 times 10? 3 times 10
no.
isn't 15.
3. Never, my bad.
I know it's your bad.
Where's
I've
the
proved my point. Go
where-
sit down. Stop talking when I'm teaching because you don't know what you're doing either. Ooh, the seat's all warm now. It was warm when he sat down. He was just too polite to say. Which is rare, because he's not usually polite. So, what we have here, of course, if you don't remember how to do it, there's a few ways to do it, but I don't care about every other way. I'm only going to show you my way because I don't care. I need to multiply to negative 30 and add to negative 7, which is m plus what? 3 and m minus 10. But it is not 3 and 10. It is divided by 2 because I had this 2 at the front. So it is 2m plus 3 and m minus 5. Now, if you use that box thing that people from other countries use, go ahead and use it. I don't care. If you use guess and check, go ahead. I don't care. If you use decomposition, go ahead. I do not care. But get the answer. Over. How do I factor that?
Get out the 2m.
Get out a 2m, and that leaves what?
M minus 5.
M minus 5. How do I factor that? Two m plus 3, 2m minus 3. Where should I put it, though? I should put it on the bottom. Because this is multiply times, what's this guy? 3 minus 2m. Now, doesn't that look very suspiciously like a bunch of other stuff we have?
Yeah.
So what should I do?
Get out the negative.
Take out a negative 1 and rewrite it as 2m minus 3 over 1. Is it factored?
Yep.
Where do I check for restrictions?
The denominator.
Denominators and any numerators that division is involved. But I don't need to check that guy because he's a 6. So, m cannot equal what here? 0 and 5. M cannot equal what here? Positive or negative? 3 halves. And now, have I factored everywhere? Have I checked restrictions? So what's the only thing left to do? Cancel, cancel, cancel. Where? Everywhere I can. M minus 5, M minus 5. Can they go? Yep. 2m plus 3, 2m plus 3. Can it go? 2m minus 3, 2m minus 3. Can it go?
Yeah.
What's left? 6 and negative 1, negative 6 over
2m.
2m. Is it done?
Yeah. No. What?
If you handed negative 6 over 2 to Mrs. Bag Crumble,
Oh, yeah, right.
What is it?
3m.
negative 3 over m. Is there anything in this unit yet that you have seen that is new? Not one thing. But you've had to put together grade 4, grade 5, grade 9, and grade 10 in order to do these one questions. There's your work, page 129. Did I supply you with answers? I didn't. What shall I do with that? It's regular homework. But you've no answers. So you have to have some faith that you know how to do math. Will you give up? Of course not. Because you don't know if you were doing it right or wrong. Will you do it all in pen?
No.
Of course not, because you might make a mistake. When will you see the right answers?
Tomorrow.
Tomorrow. Go.